Okay, so, ladies and gentlemen, let's kind of review a little bit about what it means to be a polygon, what it means to be a regular polygon. So who can remind me what it is to be a regular polygon?
All sides are equal.
Okay, so all the sides are equal. Let's write that down as a reminder. So all sides are congruent. All sides are congruent. Okay, what else do we know about regular polygons? All angles are congruent. All my angles are congruent. So when we look at finding the area of regular polygons, there's a formula that we're going to discuss today that you guys need to add onto your reference sheet. And the area for a polygon is 1/2 PA. So half of a Pascal. If you don't know what Pascals are, I'm sorry you missed the joke. So it's 1/2 PA.
Well,
Exactly. Now, what do we see up here? What is this image that we have up here on the screen?
it's a circle around it.
It's a circle around a polygon, right? Okay, notice now what's special about that circle and the polygon?
There's empty space between.
Kind of. Bailey? Every vertex of that polygon sits on the circle. Every single vertex of that polygon is sitting on the circle. That is what we call circumscribed. Now, every circle has a center. It's the intersection of all the diameters of the circle. So let's say that, we'll make things simple here, we'll say that that's the center of our circle. The center of that circle is the same as the center of the polygon. And then we're going to add two terms today. One of these you guys have seen before with circles, and that is the radius. And the radius of a polygon is the same as that of the radius of the circle. It is the distance, if you want to write this out as a definition, it is the distance from the center of the polygon to the vertex. Write that down, Cheyenne. The radius is from the center to the vertex. So again, if we're going to model that, that would be our radius. And then there's this really weird term called the apothem. Not the apophthegm, not the stuff we eat off the side of the road. It's the apothem.
I still didn't get
Yeah, I know you know. That's fine. We're not far enough south for you to get that joke.
that. Oh, a possum.
There you go. Okay. So when we think about the apothem of a polygon, it is the segment from the center to the side of the polygon. And it has to be perpendicular to the side of the polygon. And so that is our apothem.
How do you spell that?
Right there, Sam.
Makes sense.
Now the apothem does a couple of things. The apothem will bisect the side. That's worth mentioning. We should probably write that down. The apothem bisects the side. What does that mean?
Splits it in half.
Splits it in half, cuts it in half. And if you notice, with the radius and the apothem and my side, what shape did I create up here?
Triangle.
What type of triangle?
45, 45.
No.
Just a right.
A right triangle. Okay. So it's a right triangle. Now, another thing that's worth mentioning, suppose I drew another radius.
It'd be
How does
like
this radius compare to that radius?
the same.
They're the same. So when I draw my two radii, what type of triangle does that create? isosceles. Which means my apothem not only bisects the side, but it also bisects the vertex angle. Okay, so write that down. It bisects the vertex angle of the isosceles triangle. So we have this really weird formula, 1/2 PA. What do you think the P represents? Morgan Vogel. What do you think the P represents? No idea? Okay, well look at your reference sheet. When we usually use the word or the letter P in our formulas, what does the P actually represent? Perimeter. So we're talking about a polygon, what do you suppose we're finding the perimeter of?
This.
Finding it of the polygon. So where does this thing come from? And then, to me, that's just a great question. Where does this thing even come from?
Where does what come
Where does that formula come from?
from? 1/2.
1/2 PA. Huh. Well, let's look at that a little closer. So let's do this. Let's erase all this stuff. Okay, maybe I don't want to. Okay. So we're gonna start off. Suppose I drew all my radii. So let's do that real quick. Let's draw all the radii. By the way, how many sides is this particular polygon? 5. How many radii did I draw? How many triangles did I just split my polygon into? 5. 5 equilateral triangles. Do we agree? Okay. And although it's regular, let's just label these sides as side 1, side 2, side 3, and so forth. So there's side 1, side 2, side 3, side 4, side 5. So if we do this, and I say, hey, I want to find the area of this polygon, what do you think would actually might be a little bit easier to do?
Oh, from the area of your triangle.
Find the area of each triangle and then add them all up, right? Well, how do we find the area of a triangle?
Oh.
1/2 base times height. Well, for each one of these triangles, what's the base?
One side.
It's the side. And the height,
It's the radius.
not the radius, the height is the
Oh, that.
apothem, which we don't know yet, which is fine. We're going to leave that as the letter A. So that means the area of each triangle is 1/2 side 1 times the height, which is the apothem. But now, how many different triangles do we have?
5.
5. So if I want to find the area of my polygon, the area of my poly is 1/2 side 1 times A plus 1/2 side 2 times A, 1/2 side 3 times A, plus and so forth, all the way out to 1/2 side N times A. So that's a very long summation there.
Can't you just multiply it by 4?
Well, Sam, there's something I'm going to show you where we get the P from and why we use the perimeter. What is each one of those terms? What do they have in common? Each one of those terms has 2 things in common. They each have the half and they have
A side.
an A. Because the sides, we can think of them as being different. But it's 1/2 and an A. And so back from algebra 1, we can factor out 1/2 A. I'm left with side 1, plus side 2, plus side 3, and so forth all the way up to side N. And then guys, what do we call that collectively? When you add up all the sides, we call that the perimeter. And that's how we get that formula. It's 1/2 PA. We're just adding all the pieces. So let's put this right into application. So here we go.